Good morning, everyone, and welcome to the Airways of Hope webinar series. Thank you for joining us. My name is Michelle Wright, and I am the Coordinator of Patient Program Initiatives here at Lung Cancer Canada. Our topic today is radon and other non-tobacco lung cancer risk factors. Our speakers are Dr. Erin Goodarzi and Diane Colton. Dr. Goodarzi is an associate professor at the University of Calgary, director of the Robson DNA Science Center, and lead of the science communication for the UBC's Charbonneau Cancer Institute. He's also the founder and scientific director of the Evict Radon National Study, a publicly funded transdisciplinary multi-site Canadian research project aimed at understanding the risks of radon gas exposure in the home and improving accessibility to early cancer screening for those exposed to non-tobacco risk sources. Diane Colton also joins us. Diane is the owner of Mobility Financial Services, but joins us today as a lung cancer advocate. She's a 3-time lung cancer survivor and founder of the charity Unmasking the Reality of Lung Cancer. She's worked with Dr. Goodarzi to increase awareness of the issue of radon in Canada and the role it plays in lung cancer risks. Thank you both for joining us today. You'll see in the bottom of your screen, there's a Q&A box. If any participants have questions, please enter them there.
Okay, thank you so much for that very kind introduction. So in the next half an hour, I'm going to be speaking to you from here, the Charbonneau Cancer Institute, which is in Calgary. You can see there are a couple of shots of our buildings there, where we consider all aspects of the cancer problem, all the way from prevention through to long-term support for survivors. And my care right now to talk to you today is focused on lung cancer, and specifically the early detection of. Canada certainly has a lung cancer crisis. This is a figure from the 2020 statistics report from the Canadian Cancer Society that concluded that Canada had amongst the highest lung cancer incidence and mortality rates in the world. If you were to overlay this with worldwide tobacco usage, you would see a very different picture, because Canada is certainly amongst the lowest of tobacco usage. And so that really becomes a theme of non-tobacco sources of lung cancer, which underlie what's going on today. Now, why do we have such a high mortality rate? Unfortunately, that's due to the reality that lung cancer in Canada today and over the past sort of 30 years is unfortunately diagnosed too late. Typically here you can see 50% of patients are being diagnosed at stage 4, with another 20% at stage 3. Those stages are certainly more complicated to treat. And for the reason that stages 3 and 4, you can see through this diagram here, are the stages where the tumor has spread more extensively and perhaps even throughout the body. If we're able to move that needle from diagnosis at stage 3 and 4 to stage 1 or 2, survival multi-years post-diagnosis is far, far better. And so it sort of the motivation is to see how we can detect lung cancer, which is often very hidden until later stages from a typical physician, if we can diagnose it much earlier through new screening techniques. Now, the technology to do this exists. In fact, low-dose CT scan is a demonstrated effective tool to detect lung cancers at the earliest stages. You can see that little arrow pointing to a spot that would be very early stage at that case. And this is something that was published now more than a dozen years ago. In summer of 2011, in the New England Journal of Medicine, was the first incidence where the technology was demonstrated to function, having been piloted throughout the 2000s. At this time, the screening thresholds that have been developed, where you meet the criteria, you have to demonstrate this, which is a 1.5% risk of lung cancer over the next 6 years. That calculation is based on the fact that a CT scan is not without risk, and so you don't want to be screening everybody who do not need it. But if you have at least a 1.5% risk of lung cancer in the next 6 years, you're deemed to be above where you gain a benefit from actual screening. And so how is that risk calculated? And that's a big focus of what I'll talk about today. And so at this time in Canada and through most of the rest of the world, to meet that risk criteria, you have to be the following. You have to be within about 55 to 74 years of age. You either have to be a current tobacco smoker or have quit within the past 15 years. And your tobacco smoking history has to equate to around 20 to 30 pack years. There's some nuances across each province, but generally speaking, it's this and not much else because of the difficulties in calculating risk from non-tobacco sources. So that means, unfortunately, at this time, that if you look across a population, 40%, including everyone who does not smoke tobacco, who will get lung cancer, would not be eligible for lung cancer screening based upon current criteria. And so it's certainly recognized as a health injustice issue, an inclusivity issue that needs to be addressed. And so how do we do that? One of the things that I'm going to highlight is an article from the front page of the Toronto Star that was published only a few weeks ago that really highlighted this issue. And you can see there the title of the article. She found out she'd been breathing cancer-causing gas, meaning radon, for more than a decade. And so why won't Canada's healthcare system let her get her lung tested? And the article was really speaking to the fact of that right now, lung cancer screening programs can't include non-tobacco sources of lung cancer in their criteria. If you look at the comments on that one, I was struck by one from someone called Marion, posted 20 days ago, who described her stage 4 lung cancer story where she was diagnosed last autumn. And I'm just going to draw attention to this one section where she indicated if a routine x-ray of my lungs had been done earlier alongside other tests, this lung cancer might have been caught much earlier. And she pointed the fact that, yes, she smoked at one point in my life, but quit when she was 26. She's 62 now, based upon what she wrote. She actually wouldn't be eligible for screening because her use of tobacco was too long ago. Yet, this is someone who's experiencing stage 4 lung cancer. So how can we do better based upon the experiences of real people? 1 in 5 people who experience lung cancer in Canada right now have never used tobacco at all. And another person in there has not used it enough to meet current cancer screening criteria. And so what can we do for these? It really speaks to the fact that lung cancer has many triggers that aren't tobacco. And the ones that we know about include things like air pollution, whether that's from an industrial source or natural sources such as forest fires, which are certainly right now where I'm sitting here in Alberta are a major issue and increasingly an issue each year. Things like asbestos that have been known for a very long time now, since the middle of the 20th century. Heavy metals such as arsenic, that's certainly a big problem if you live in Atlantic Canada or Northern Canada. But across the whole nation, radon gas, which is radioactive, is considered the second leading cause of cancer. But most of us will be exposed to all of these to a certain extent at some point in our lives, particularly radon and air pollution, which are pretty hard to get away from in Canada. So without going into too much of the biology of this, what I wanted to highlight is of the 5 major causes, triggers of lung cancer, whether that's the metals, particulate matter, air pollution, tobacco smoke, severe lung inflammation, or radioactive radon, they actually end up all working kind of the same way on our DNA. And I'll speak a little bit about that later. This is why all of those things, while they may seem very different and indeed have very different sources, they end up doing kind of the same things when they're in our lungs in order to trigger cancer. And those risks of exposure get modified by lots of other variables that are important to understand, such as, how fit we are, our relative age, our family histories of cancer, as well as our family histories of many other things, what we might have done for a living, whether our job is inside in an office, in a house increasingly, or perhaps in a vehicle or in other environments. And then, of course, our history of lung cancer. My colleague, Dr. Dan Brenner, published years ago now that previous history of lung diseases, including tuberculosis and COPD, do come with an increased risk of lung cancer. It remains to be seen whether that's also true for COVID, 19, but certainly classic standard pneumonia comes with a significantly increased risk of lung cancer. Every time you get pneumonia, you might add a little bit to that risk. And if you're then also exposed to something else, such as radon, that would amplify it. And so in the modern world, we have lots of these non-tobacco sources of lung cancer. We need to understand 4 major things in order to calculate the risk. What's our likelihood of being exposed at all? So for example, in the context of radon gas, if you work outside and you live in a treehouse, you're probably never going to be exposed to radon. But if, like most people, you work inside at least some of the time, and you live in a house that's on the ground, it's a question of how much and for how long, modified by your personal family genetics, your history of infection, and then your behavior, meaning what you do for a living, how much you exercise, what you eat, and other factors. So we have to understand all of these things in order to get to that magic risk factor number that means inclusion or exclusion from a lung cancer screening program. So now I'm going to tell you a little bit about radon itself. So what is it? So for those who aren't familiar, it's basically a source of particle radiation. Radon is generated throughout the Earth, deep underground, and migrates to the surface, where normally it evaporates or is dispersed, I should say, on the wind to quite low levels in outside air. Radon is unstable, however, and will emit what's called an alpha particle, a type of radiation that moves at 15,000 kilometers per second with enough energy to dent bulletproof plastic. We measure radon in a unit called the becquerel, which essentially means 1 radioactive emanation every second. So one of those 15,000 kilometer per second particles that are denting bulletproof plastic per second, that is 1 becquerel. And we actually use little squares of CR39 bulletproof plastic, you're seeing there in that little blue image, inside what often looks like a little hockey puck or ant trap to measure this. And if you know the start and end date of a test, you can actually then pop out that little chip, etch it with a few chemicals, and use a microscope to count the dents, to literally count the dents. You can see there what it's doing to bulletproof plastic. Imagine what that's doing to lung DNA. And so historically, we've not really had much of a radon problem until, say, the middle of the 20th century, because, as I said before, in your front lawn or in a field, radon's coming out of the ground and being diluted very, very quickly on the wind to almost nothing. But in modern houses, radon is being captured, contained, and concentrated to now cancer-causing levels. And for the first time, we as a species, humanity, are living long enough and inhaling enough radon for it to be triggering lung cancer. And so to go into that a little bit more detail, how radon impacts our health, we have to understand a few things. First up, radon is a gas and we can inhale it, but it then in our lungs very often radioactively decays to solid metals and very quickly will become solid radioactive lead-210. And so you can be in a building with high radon, inhale that, and walk away with the solid radioactive lead in your lungs, which won't go away because it has a half-life of 22 years. And like all lead, most of it will be retained in your body for life. The other thing is then, okay, so we have radon and its decay products in our lungs, and it's emitting this alpha radiation. It then really becomes a question of our DNA. And so here I'm showing you very nicely colored units of DNA from a female cell. You've got 22 chromosomes. You can see those are the little colored squiggles. In this case, 2 X chromosomes. And as we're born, most of us have relatively unscathed DNA, meaning it has not accumulated a lot of damage. But as we live and grow and age and are exposed to a lot of our environment, that DNA is subject to damage from things such as air pollution, ultraviolet light, so too much suntan, inflammation from disease, as well as things like radiation from radon. That damages the DNA, and that is what really drives mutations that underlie cancer. And so one of the things I often get asked is, so why is this particular type of radiation so dangerous compared to, say, other types that we might be exposed to, like an X-ray? The reason is this, is that alpha radiation from radon actually is heavy and has mass. It is the #1 way we are exposed to radiation throughout life. If you're a relatively healthy individual who's never had a CT scan, that blue part of this pie chart, artificial, is going to be almost nothing. And depending on where you live, the radon may be greater or lesser, but it counts for most of our lifetime dose of radiation. I explained the becquerel. I'd like to explain 2 other units for you before I get much further. The way I often describe this is to visualize yourself sitting under an apple tree. The source of the radiation is the tree, so that would be the radon. And the alpha particles, those little 15,000 kilometer per second bullets, those are the apples. 1 becquerel is 1 apple per second, right? One number of radioactive events per second. And so that's simply the number of these things being emitted from radon at any given time. Now, in biology, we actually really only care about the apples that hit us, and that's the absorbed energy. And so that's a unit called the gray. And in medicine, we actually only care about the apples that hit and also hurt, meaning they have a measurable biological effect. In case of alpha particles, every single apple that hits you hurts you. And so 1 gray is 1 sievert. Sievert is a very important dose because that will be the unit that we end up using to consider people for lung cancer screening. It's so cancer causing because compared to an X-ray, which moves very quickly through our body, the X-ray is just a type of light. That's why it's great for imaging. Particle radiation, like alpha particles, move slowly, and they deposit all of their very damaging energy over a very short distance. That makes it much more difficult for our bodies to repair the damage to DNA caused by radon gas emanations. And one of the issues is, as I explained before, it's only in the past 100 years at most that we've ever been exposed to particle radiation in the doses we're now seeing. And because of that, we have not evolved the natural repair mechanisms that we have very effectively for X-rays and other things such as oxygen, such as infectious disease, sunlight, or even consuming alcohol. We just have not done this for particle radiation because we have not evolved in environments such as deep subterranean caves where you'd find high radon, living right close to the grass where you would find high radon, or out in space where you would also find particle radiation, not radon per se, but in cosmic radiation, which is very similar, which might have applied a selection pressure. We don't have normal repair mechanisms for radon gas emitted alpha particles. So essentially, the damage it causes is alien to our bodies. And that makes it incredibly difficult for our bodies to respond to it, which is why it's so cancer causing. Okay, so it's all about our DNA. And the reason for that is because the damage it produces will move a cell from the nice normal. You can see there on the left, this is a male cell in this case, 22 chromosomes and an X and a Y, to cancer. And the genetic face of cancer is on the right in panel B there, where you're missing some chromosomes. You have multiple copies, more than 2 of other things. And then at the bottom, those monsters that you can't even recognize because they've been cut and rejoined and are mutated. That is the genetic face of cancer, and that's what indeed particle radiation will do. And per dose, it's extremely cancer causing. Here you can see there on the y-axis on the left-hand side, the excess incidence of cancer, and on the bottom, the absorbed dose of radiation. You need a very high dose of that photon radiation, like an X-ray or a gamma ray, to start to move that needle even a little bit off the ground in terms of excess incidence of cancer. But in the case of particles, you don't need much for it to do something. And so when I often explain this, what I say is, if you think of that photon as something, you need an awful lot of that in order to move cancer. It's a bit like that laser in Star Wars that always misses. Most of the photons that hit us will miss our DNA and not do much, where particle radiation is that thing that always hits. And indeed, it's much more like, unfortunately, that Death Star that can blow up planets in Star Wars. And in fact, if you compare the mass, it's exactly what that's doing. If a photon's a single bullet at the side of a building, a particle is a particle of alpha particles. Is more like a 580 square meter carpet bombing of the building. Your DNA is not going to be okay. And so we now know, based on multiple landmark studies from the mid-2000s, one from Europe, one from North America, one from China, all came to more or less the same conclusion, that for every for every 100 becquerels per cubic meter of radon we would inhale, so that's 100 alpha particles per second per cubic meter of air, our lifetime risk of lung cancer goes up by 16%. So if you inhale 200, that would be 32%, and so on upwards. International Agency for Research on Cancer classifies radon as category 1, meaning we absolutely know that it causes cancer in humans and also animals. And so radon is prevalent in our modern built environment. And again, I keep stressing modern built environment, not the old built environment, the modern one. So, you know, when we used to live in castles and caves and sort of mud huts, there was no radon in those, not at significant levels. But today, our buildings look very different. To understand the radon problem, you have to understand three things: location, so that means the geology and the geography of the area; the built environment, and so what kind of buildings are there; and then, of course, the behavior and demographics of the people inside. And collectively, that underlies the Canadian radon issue. So to illustrate those, for example, location matters. While everywhere in Canada has some radon risk, one of the things our teams have observed quite recently is that there's a bit of a divide between urban and rural. So if you define urban communities, and this is in fact how Statistics Canada defines them, between sort of cities and large towns, meaning if you're in a city, it's a place with more than 100,000 people. Large towns, anything over 30,000, versus more rural areas, which go all the way down to a single person in one house in the middle of nowhere, to small towns with 1,000 to 30,000 people. What we find is that rural communities have innately higher radon exposure risks of about 13%. This is true across Canada, and you can see it there. So the average radon in a house in a rural area, for reasons that we're starting to understand, and if you're curious about that, you can ask me in the questions later, are innately higher. So location matters. Buildings matter too. We occupy in our jobs and in our lives, and when we're at play or vacation, all sorts of different types of buildings. Each of these can have their own nuances, and across Canada, we've been mapping these. Every one of these dots that you're seeing there is a single Canadian house, and we've been mapping this in the residential environment, at least, for some years now, and are finding some extraordinary amounts of radon in the many, many thousands to tens of thousands of becquerels per cubic meter. And, you know, we're starting to understand why this is the case, and are coming up with lists of building features, including when the house was built, what does it look like, how big is it, and others that are allowing us to predict whether a given house may be high or low for radon of a certain level. So buildings matter a lot. And then finally, populations. Of course, all comes down to people inside who are breathing it in and modifying their lung cancer risk. So for example, our activity pattern. How much time do you as an individual spend per day in your primary house, someone else's house, family, friend, non-residential buildings, classic workplaces, the mall, and restaurants, versus outside or in a vehicle? And because all of those things will have very different radon risks, it's important to understand those. This is very much often a function of what we do for a living. Do you work from home? Do you work outside, etc.? And we've been, you know, trialing that and understanding it. What we know from our work and that of others is that 84+% of Canadians spend, Canadians spend 84+% of their life inside. Of that, 2/3 of life is in your primary house, meaning that the radon level of your primary house is contributing 2/3 of your radiation risk. That, of course, matters whether you work away at an office or work from home, or perhaps you're retired or on some sort of leave like maternity leave or disability. And if you understand the radon level plus the amount of time people are spending in, you can go from the becquerel to units such as the sievert. And this is really important to understand exposures. This is the only map I'm going to show you here, and that's how we get from one to the other. And you have to understand only two things: how much radon is in the building and how much time people are spending in the building. And if you know those two things, you can actually calculate their radiation risk. And this is putting the doses in context. This is going to become really important for lung cancer screening. We know at a baseline that Canadians have about 3 times the global average exposure at about 3.6 millisieverts per year. And to put that into context, just over twice that is about the dose you would get from one typical whole body CT scan. So the average Canadian is getting a CT scan's worth of particle radiation per year simply because of living in their house. Many Canadians are much higher, and each one of those dots you're seeing there in gray represents one Canadian. We have large numbers that are experiencing 20 to 1,200 millisieverts per year to the lungs. This is far in excess of what an astronaut on the International Space Station would get, much more than a nuclear energy worker. And it's unsurprising that consequently our lung cancer risks, despite having historically low tobacco rates, remain much higher compared to other nations. For example, 163% higher than Sweden, despite very comparable populations, because our radon risks are so much higher than the global average. One tool we have developed through the Evict Radon National Study, which I lead, which you can find on the study website right now, I'm giving you the URL there, allows you as a person to sort of calculate your personal exposure. So we ask, what sort of house you live in, how many of those do you have? Maybe you have a cabin and a primary house. How much time you spend in them, do you work? Is your time different on a weekend versus a weekday? And you can fill out also if you know your radon level. So here I sort of filled it out, someone who lives in one primary house, their weekend looks a little different than their weekday. They perhaps spend 16 hours at home on a workday and 22 hours at home on a weekend. They have 200 becquerels per cubic meter, and they've lived in that house for 10 years. They can put that in and pull out and get a millisievert per year dose, and put that into context for all of the other Canadians that we have in our study. It also gives you the projected estimated lifetime risk of cancer. In this case, for that person at 200 becquerels, that would be 32% risk. Estimated. So welcome to play with that. This is a useful tool. Is it sufficient, however, for lung cancer screening? And the answer is no. This is good, but it's not perfect. And that's because the problem is we do not have a radon test for everyone, for every building they've ever lived in going back to birth. And that's really what you need, long-term exposure information in order to do this. So to go back to that Toronto Star article, there was another comment from a person called Paul, who 19 days ago when the article came out, had a comment. And this person's comment at the top really also hit the nail on the head. It is probably not practical nor even beneficial to extend low-dose CT scan screening to every non-smoker in every house that gets a measurement over the 200 becquerel threshold. And what that person's referring to is that in Canada, Health Canada indicates that anyone in a house at or over 200 becquerels should mitigate quite quickly. He goes on to talk about the nuance between the United States and Canada, but he highlights the fact that how long were people exposed to that, and do they use the 1 year average? And so they're illustrating the fact that we do not have a long-term lifetime radon exposure for everybody. And in fact, the typical person might have a single 90-day test somewhere between their 20s to 60s. And in fact, in the Evict Radon study, we know that typically that occurs between the age of 40 to 50. And so what do we have to do? We have to solve that problem. We have to understand radon exposure throughout life, from childhood, no matter where you come from, and no matter what you do for a living. And so that's what we've been doing. And so I'll close in my last 5 minutes by explaining exactly what we have been doing. We've been finding a better way, ways of calculating long-term radon exposure based upon our bodies. And we've been looking for that holy grail, the so-called blood test for lifetime radon exposure. And finally, the technology now exists in order to do that. And it's a little picture of an inductively coupled plasma mass spectrometer. I'll refer to that maybe as a mass spec from now on. And we take advantage of that thing I told you before, that radon will accumulate as solid radioactive lead in our bodies. And we can measure that now in a sufficiently sensitive enough manner to look at long-term accumulated radon. To do that, we're actually not using blood, we're using toenails. Why toenails? Well, radon decay products, believe it or not, do end up in our toenails, our hair, our fingernails. People are usually not so squeamish about providing us toenails. They're easy to store and they work. And so if we know someone's exposure, because we know the radon level in our house and they tell us how much time they spend there, we can also get them to give us toenails. This is all based on an idea that dates back to the 60s. So in the 60s, scientists published that, yes, these things accumulate in tissues, but it's only really in the last 5 years that the technology to detect them in a sensitive enough manner exists. We have to get down to very low levels. So here you can see, you probably heard of a milliliter or something, or a centimeter. We actually have to get down to femtograms of this lead-210 in order to be sensitive. So to do that, we have to build very fancy metal-free laboratories where we can get down to this magic 10 to the minus 15 number. And so we have been doing that. The key idea is we got the radon exposure from Canadians. They supplied us with their toenails. We had all of the tech in place. We can detect it in a sensitive way. And we had 75 people over the past 3 years that one group of 25, they had high long-term radon exposure. Another group of 25 people had low long-term exposure. And we had a control group with high short-term exposure, worked out in millisieverts to be what I'm showing you on the bottom there. We controlled for whether they smoked tobacco, if they worked down a mine, and even strange things you might not think about it, how much moose meat they ate. That's because moose meat weirdly does contain a lot of radon decay products because they eat lots of lichen and moss in the forests that can absorb these things. And we actually looked. We had the two groups there. One group that we knew was low exposure, so less than 25 becquerels. That's not cancer causing. Over 10 to 30 years, they maybe got 16 millisieverts. And the other group that were averaging of close to 500 becquerels, that is very cancer causing, at close to 300 millisieverts. And what was tremendous is that we saw a massive difference. In fact, we saw 460% difference in the amount of lead-210 in femtograms per gram of toenail in their toenails. And so now, although this is preliminary finding, this has laid the groundwork for a major study, which I'll announce now. We of course thought about what we needed to do, which was a clinical trial, getting government approval to do it and funding it. And through the Canadian Cancer Society, we sent an application in last year. This was a team involving folks from British Columbia, Alberta, and Nova Scotia. And we have attained about $5.2 million worth of funding to do a clinical trial for lung cancer screening for people who do not smoke tobacco. This has two arms to it. It will come as first measuring these actual lung cancer triggers that aren't tobacco. We, of course, will understand anyone's tobacco use history, whether or not they've been exposed to things like particulate matter, arsenic, but the one I'm leading within this, which is about $2 to $3 million worth of the funding, is being dedicated towards radioactive radon gas. So what we have to do is we have to recruit about 2,500 people. That's about what 2,500 people look like. So an entire auditorium's full of toenails from across Canada. We'll also be doing this with an additional 2,000 samples from people experiencing disability, who often, the way they occupy the built environment is different, as well as another 750 samples from people with long COVID to understand that. We take the toenails then, and we have to analyze it in a brand new facility that's under construction right now. It'll be open by the fall, which has been funded by the Canada Foundation for Innovation, where these new fancy mass spectrometers will be located. Where we're also doing things like looking at cancer mutation signatures, where we know the tobacco signature in a tumor. We don't know it for radon. And so we're looking for that using brand new technology we've invented to deliver alpha particles to lung cancer specimens, and looking at other biomarkers, whether those might be in your blood, your DNA, or even your gut. Looking at all of those things. Now, the second arm is that once we identify people who we know have had high exposure to radon, meet the other risk inclusion criteria, we will then move those people forward for actual low dose CT scanning. That'll happen in years 4 and 5. And so of the 2,500, 3,000 people that we'll be getting toenails from, we will be screening approximately 1,000 of them who meet the criteria and see if we can detect nodes at a significant level. Right now, that will involve teams, again, as I said, in BC, Alberta, and Nova Scotia, looking at all of these non-tobacco sources. And so the other teams involved will be looking heavily at arsenic and air pollution at the same time. So if you're interested in any of the studies I've spoken about, you can find them all on the Evict Radon National Study website. They're free for download, acknowledging all of the different partners we've had, certainly the funding organizations and those involved. And so at that point, I'm done, I will give over to Diane.
Thank you, Aaron. Thank you for that, as usual, absolutely wonderful discussion about radon and taking it down to a easy, understandable level. And I always loved your graphics. Anyways, so Michelle, can I make sure that we're both still on the screen, because Aaron and I are just going to be chatting. I could talk about my lung cancer journey and all of that, but I don't think that's the important thing today. I think what's important is talking about radon, talking about ways we can all help and do things. So Aaron, so we know, and by this discussion, and I know from working with you on and off over the last several years, that radon is such an important piece of the lung cancer puzzle. But why is it still so unknown? The number of people that I actually talk to that look at me with glazed eyes because they've never heard of radon, they know nothing. So why is it, and how can we help fix that?
Mm-hmm. There's a couple of pieces to that. Literally, radon is invisible to all human senses, right? And so humans have a tendency to downplay what they can't see, hear, smell, taste. So that's part of the issue. Second, Canada historically has been a little bit delayed in how we've been communicating radon to the public effectively. We have to reflect on the fact that really we only started doing that around 2008. And before that, the government thresholds for action were very, very high, and it wasn't a priority compared to other nations. So we're playing catch up. So that's part of the issue. If you speak to, for example, your average American citizen, they probably know a lot more about radon than your average Canadian because they started back in the 80s. So there's a 20-year lag there. And then, of course, from another medical and scientific perspective, it's really hard to study. Literally, we had to invent the technology to deliver alpha particles to just cancer specimens, lung specimens in the lab in a way that didn't involve building a multi-billion-dollar particle accelerator. And so the democratization of studying this has just happened in the past 5 years. All of those reasons, that's why we're behind on radon.
Okay, no, that's great. And yeah, I know we've talked about this, and research is so vital, and understanding how radon works within the human element and what we breathe in. So when you look at that, you have people being exposed to radon, right? Some of them from birth up until 1820, because either their house is new, and it doesn't necessarily matter if you move to a new house, that the radon is still there. And I also know that we're starting to see younger people get lung cancer and being diagnosed with lung cancer. How direct is radon to that? Yeah,
that's something that it's considered the second leading cause of lung cancer because of the prevalence of the exposure across the nation. It also is synergistic with tobacco. So one of the questions is how many people who have used tobacco might not have had a tumor had they not also been exposed to radon. We will know unequivocally whose tumor is caused by radon and whose tumor is not once we have that gene signature I spoke about, because we'll be able to just look at the genetic sequence of the tumor and the mutations that are in there. And just as we can do for tobacco now, I don't need to know anything about someone's tobacco history in order to say, oh, well, that tumor was due to tobacco. We will be able to do that for radon once that data emerges, and that's about 3 years away.
Yeah, I know. And I wanted to thank you for the information regarding smoking, because I come from a family of 9 people. 8 people smoked. My mother didn't, but had to live with all of us, which I'm sure she was not overly happy about. But I'm the only one in the family who's ever had lung cancer out of everybody. So you know for sure that it's not just the tobacco, and from my living habits and places I live, radon probably has something to do with it, and any number of things. So I think it's really vital that we all kind of grasp and stop the smoking stigma with this, because it's not necessarily true. 4.2 million people smoke in this country, and the numbers of direct contact with smoking that are current smokers is it's 15,000 out of 30,000 a year. So, and I know radon has a big effect on that. Radon also has the effect of, if you are a current smoker, former smoker, never smoker, getting pneumonia and then being subject to high radon levels. It's a huge mixed bag now. So how can we as patients talk about this with the public, and are there materials available for us? How can we work with you to help this, because it's a preventative event and symptom
So
and state.
exactly. So there's a whole bunch of things that any citizen can do. So first up, I would say to anyone in Canada, right? So Health Canada, our study, others have lots of resources you can download. Just reshare links. Have that conversation if you ever test your radon. And I would say if you have anyone in your life that's bringing a new baby home from the hospital, new parents, that's the best time to have the conversation. Instead of the baby shower gift, get them a radon test. I have a lot of grandparents in our study who buy their adult children who are just bringing the grandchild home a radon test, right? That's the period where you'll get if they test, and if it's high, great. If it's low, great. If it's high, it's still fixable. All radon in Canada is a fixable problem. It's a minor home renovation. It's a permanent fix to the house. It does cost about $4,000 to $5,000, as I understand it today, but weighed against the cost of being lung cancer risk free, as far as that's concerned, I would argue it's money well spent. There's equity issues with regard to how much it costs. That's being looked at and examined right now to what we can do about that. Other things. So if you are someone who has experienced lung cancer, your stories are incredibly powerful as testimonials for other Canadians. One of the things that the national study is looking at doing is capturing those who are willing to share those stories, whether we can do that through print, promote that. We work together with investigative journalists. We work together with storytellers, medical doctors, in order to tell those stories. If you're interested in telling your story, we can make that happen. You just have to contact us via the national study. All of our contact information is on the site. One of the things, I'm just going to quickly reshare my screen here, that I think would be immediately useful. I'll go ahead one slide. Is, remember the story in the Toronto Star. One of the things with journalism that, they're facing a crisis right now, but of course, just like we used to have to pay for a newspaper, this article largely is behind a paywall. I have been told that, in fact, though, if we email or write a letter to the public editor and say, look, it's really important that everybody be able to access this story, for the public good, they will take that paywall down. And so if anyone on this call is feeling a little motivated, there's the information. Email that editor and say, look, this is a really important story. It's behind a paywall. We need to tell these stories to as many Canadians as possible. Certainly my team of scientists are going to do it. But if they hear also from Canadians experiencing lung cancer, that would be a big thing. And then things like that, right? Advocating for it, doing a lot of the activity like you do, Diane, that would be tremendous.
Yeah, and I notice on the email it's public ed, which means public education, but they have it behind that paywall. Yeah. I know it came out, I tried to get in and it was subscription. Yeah. And it is vital information for us. So Erin, I do projects, and I really would like to do a lot more projects in Calgary and surrounding areas. I'm just going to give myself a little plug, because I'm looking for volunteer patients, caregivers, to work in Calgary and area in November, so that we can go out and do community events to talk about radon, to talk about lung cancer and all the different things with it. So that's just my plug for now. So everyone knows me on Facebook who does. Michelle, I'm sure, will kind of help along the way with that. But one question that really came up for me now was, all these people are working at home now, right? So they're now going into that enclosed environment where they're subject to such higher levels of radon. What do you see as the outlook for that? And yeah, that's a little bit scary.
Indeed, that Toronto Star article highlighted our most recent study, which looked at the pre and post COVID pandemic onset radiation exposure from radon gas, and it's jumped about 20% over the period of the pandemic. And while it will return, it will come down. What we know now from long-term follow-up with our participants, it's not going back to normal. So we're the pre-pandemic status quo is gone. We kind of know this. Canadians want to work from home. Well, many Canadians want to work from home. It's being normalized across sectors and industry, and that means for those individuals, they're now going to experience innately more radiation risk, meaning lung cancer risk, across their lifetime as a consequence of this. So this has policy implications for employers and employees, and these are questions that we now have data for and are posing in terms of how we recalculate long-term Canadian lung cancer projected estimates, because everything that we thought in 2019 is kind of out the window. We have to redo all of that kind of stuff based upon our new normals across sectors. It's very much a function of where you live, right? So if you are working from home in a rural area, you've got higher exposure because of your job and higher exposure because of where you live, versus, say, those in other professions, right? So one of the things that we found in the recent study that we published, and again, you can find that on the Evict Radon website, is that for example, if you were a frontline healthcare worker, well, your exposure during the pandemic went down because you were at work a lot. If you were, for example, a judge or a lawyer or an accountant like yourself, Diane, you were at home a lot more. Scientists like myself were at home a lot more. And so our exposures went up. All those white collar jobs, so to speak, went up a lot more. And they're not all coming back down. We know they're not. So it is scary. But it's something that we're studying, is on our radar. And of course, the best thing that any of us can do, particularly if you work from home, is test for radon and reduce that exposure if it's high.
Okay, and just one last question, and then I'm opening it to the floor to ask their questions. So you hear about radon kits, different types of kits. What is the best type of kit? And when people send their kits into I know with your organization, with Evict Radon, the data goes into research, and that for me is a very important aspect of what you do, because that's how we get changes and that's how we get the research. So what should people be looking for?
Yeah, there's a lot of radon test kits out there. So disclaimer, we myself, no member of our team make any money whatsoever from any of the radon kits that are supplied to participants in the study. It's all supervised by Research Ethics Boards. So our kits are done at cost. And the important thing there is that the person who receives the radon test, who does it for a minimum of 90 days. It's a long-term radon test. Radon does a lot of up and downing throughout hours to days and even over the course of weeks. It's sometimes weather dependent, it's sometimes behavior dependent. What your house is doing is what your specific house will be doing. You can't make assumptions. And so one of the important things, and this is Health Canada's advice, minimum of 3 months, 90 days or more. A lot of people in our study do a full year of a radon test before they send it back. With our study, as you said, Diane, people who consent into it, they're at the back end, their radon test result goes to them, of course, but also to us. They also will fill out about a 40 different point metric about their properties. And we often invite people, for example, our COVID study where people filled out activity patterns, invite folks to also participate in other research. All of those in the Evict Radon National Study right now, which is approximately 30 to 40,000 households, are also eligible to be considered for some of our toenail work on looking at long-term radon, and based upon that, potentially for lung cancer screening. We're, of course, actively recruiting. I saw there was one question there about eligibility. All Canadians are eligible to join the Evict Radon study. We can get you a radon test via Canada Post, whether you live in Iqaluit to Chilliwack to Halifax and everywhere in between. That doesn't matter. All Canadians are eligible for that. We will be putting out calls in a variety of different places this year for additional recruitment. For example, we'll be trying to recruit folks who have just missed current lung cancer screening inclusion criteria. Perhaps you didn't smoke enough. We'll be trying to recruit via that. Again, we're also putting out calls for people experiencing disability. That's in a sort of phase where we're trying to recruit focus groups to understand what we need to do to support testing for those individuals. And then, of course, people experiencing long COVID. All of those groups collectively will be soliciting invites from. But right now, any Canadian can get a test by the Evict Radon national site. We will get that test to you usually within a couple of weeks or however long Canada Post takes.
Well, thank you, Dr. Goodarzi and Diane, very much. We have quite a few questions that from our guests that we would like to try to get to, and we'll try to get to all of them. So I'll start off. Tracy asked, how will you choose the people eligible for your study, as I have family in Calgary?
So as I said, to just do a radon test with the Evict Radon National, so I understand your personal exposure. All Canadians, as long as you're over 18, you can get that radon test, put it in your house and get get your radon result. If you do that, you're also then going to be considered for the toenail study, so phase 1 of the clinical trial. So what we're doing right now is, of course, if your test comes back very, very, very low, we will consider you for our control group. If your test comes back very, very high, we consider you for screening because we think you might need it. If you are in the sort of lowish level in between, there's probably nothing for you to worry about. So that would be one way to access it, and that's open to all Canadians right now.
Great. Angus asked, fascinating discussion. You mentioned the genetic signature of smoking damage. Can you talk a bit more about what that looks like for radon? Is it related to known treatable driver mutations?
Good question. Ask me in a year. Right now, my students bombarding normal lung epithelial cells in the lab with alpha particles. We'll be gene sequencing later this year, and we'll look at those signatures. It will look very different, I think, to tobacco, just due to the nature of the carcinogens involved in there. I won't wax lyrical about that right now because it gets quite complicated. In terms of treatable driver mutations, these are things that I was explaining interplay together. So you're going to have the genetic chaos caused by radiation exposure. But if you're also someone who has a driver mutation, for example, a lot of individuals of East Asian origin living in Vancouver right now have a particular mutation known to make you very susceptible to lung cancer. Are you guaranteed to get lung cancer? Absolutely not. But if you're also exposed to, say, radon or air pollutions or little tobacco and this, that, and the other, that's where they add together. And in fact, we know tobacco and radon is 1 + 1 is not 2, it's 17. It's going to be the same for all of those other mutations. So I'm going to dodge the question and say, ask me in a year.
Perfect, thank you. Mary Ann asked, are there regions within Canada that are higher for radon gas than others?
And if I could just add a little from the web, is there a reason why Canada has 3 times higher risk of radon compared to other nations?
Yes to both, and also no to both. Okay, so let's start with the first one. Are there regions of Canada that are higher than others? Yes. Is there any region of Canada radon free? No. The lowest area of Canada, I would say, is the lower BC mainland. It's still 16th highest in the world based upon how we've been looking at it. So I want Canadians to consider ourselves as part of the global community. Yes, there are areas of Canada that are lower, but in terms of calculating your personal risk, as I said in the talk, it's location, plus the built environment, plus your personal demographics. Location is only one part of that. If that's all you think about in terms of risk, that's where often we've seen historically in other countries. I'll give you United Kingdom, where I'm originally from, as a good example. They produced a radon map in the 80s, and that was the worst possible thing they could ever have done, because they said some areas were low for radon. There were many houses there that were very high, in fact, and no one tested in those areas because they assumed that they were low. Human optimism bias being very powerful. So in Canada, we don't do that. We instead say, okay, well, what kind of house do you live in? What do you do? How much time are you in there? As well as where you live. And that's how we consider the problem. And so, yeah, you could be in some of the other higher-ish radon areas. So the prairies, the North and Atlantic Canada, second, third, and fourth highest in the world. Slightly different between those. But if the house is on fire, whether you light a candle or not doesn't make much difference. That's the sort of way we think. The second part of the question, I did the location. What was the other one, Michelle?
Oh, the second part is, why does Canada have?
Why?
Is there a
Yeah.
reason why Canada is 3 times higher?
Yeah. So we actually published a study on that late in 2022 or 2021. Well, somewhere that year, where we compared Canada to Sweden, because we have a lot of radon data and building data from both nations using identical radon testing technology. One of the things that's quite striking is if you look in the 1940s, a new Swedish house had much higher radon than a new Canadian house. By 1980, it was the same. And by 2020, there was a 467% difference, where the Swedish essentially engineered out their radon and the Canadians went up and up and up. This is in part correlating with building practices. Canadian building practices, although they did not know it, and it is no one's particular fault, have exacerbated our radon problem substantially. Whereas Swedish building practices, although they did not know it at the time, made theirs much better. In part, it's how we heat our houses, forced air ventilation, natural gas or oil-fired central heating, the way our foundations look. There's not one reason, it's complicated, but it has meant that our build code has made a high radon problem. It is being tried to be addressed right now in the next build code.
Fascinating. Absolutely fascinating.
That kind of brings me to our next question, where Harvey asked, what can you do to reduce high radon levels in your home?
Right. So there's a program in Canada called the Canadian National Radon Proficiency Program. These are the radon reduction professionals. It has federal oversight and certification. This is the trade that are the professional radon reduction people. So if you identify your building property as having high radon, you can hire someone from that program with the active certification to come in. And just as you might replace a boiler or a window, they can look at why and how radon's coming in your house and design and install a system. It's usually 2 visits, one to figure out how it's coming in. They go away, build the system, get the materials, come in, and it's a single day's work, probably in your furnace room or somewhere like that, to permanently fix that building for radon. And we've looked at hundreds of houses, and it works. In Canada, we're actually lucky in a sense that radon reduction technology, due to the nature of our buildings, is a very effective nearly all of the time. And so this is an effective thing. So this is a very solvable exposure problem, much more solvable than trying to give up something as chemically addictive as tobacco or trying to avoid air pollution. Radon, no one needs to have a radon problem if they can afford to fix it. One issue is that we had a study the other year where we know that of people who identify high radon, 1/3 go on to fix it quite quickly. 1/3 just don't or delay for long term, mañana. And 1/3 want to, but can't afford to. And so that's a social justice and equity issue relating to socioeconomics that needs to be addressed.
Thank you. Elizabeth asked, you spoke about needing to know the radon numbers in a building. What is the quality of home tests used to measure radon, and are improvements needed in this type of testing?
So your Alpha Track tester that I showed you during the talk, that has that square of CR39 bulletproof plastic, gold standard, right? That works. It's tamper proof. It's not going to be confounded by heat or light or any of that stuff. strongly recommend, as does Health Canada and every other agency in this nation, to get yourself a long-term alpha track tester. Alternatively, there are digital devices. Those can come with some confounding problems. There's newer technology. There's these things, there's charcoal tests that is used widely in the United States, not recommended in Canada, in fact, not allowed in Canada because of how easily those can be falsified, as well as just accidentally giving you a bad reading. But those little hockey pucks or ant trap looking like devices, those are great. And those really work with 40 years worth of evidence to tell you how well they work.
Great, thank you. Just keeping in respect of time, Stephen asked, so to be clear, at some point down the road, not too far, they will be able to tell me if my lung cancer was caused by radon exposure. Fascinating.
Yes. If this works, which it did for tobacco, and so I have every expectation, as does the people who funded our teams to do this, CIHR. It's a $1 million project to get this going. And so my hope is in the next few years, if all goes well, which so far so good, we will be able to do that.
And last question comes from Grace. In general, how long exposure to radioactive would cause lung cancer? I was working in projection system lab for a couple of years. Not sure if it has caused my lung cancer. I'm active, I eat healthy, a non-smoker. However, I still have lung cancer.
Most of the sources of lung cancer, like tobacco or asbestos, we know there's a 10 to 30 year lag period. So exposure 10 to 30 years ago could mean cancer today. So that's why with our radon exposure test, all we need to get is the most recent 1 to 3 decades worth of exposure in order to inform today's lung cancer risk. That we know that's true for asbestos. People started to be exposed to asbestos in the 50s and 60s. Cancer peaked from that in the 80s through 2000s. Tobacco is somewhat similar. It will almost certainly be the same for radon. Of course, that's dose dependent. If you're exposed to extraordinarily high levels, it will be a little faster. If your genetics mean you're innately susceptible, it may be a little faster. But typically, you're looking at a 1 to 3 decade lag from exposure to diagnosis with cancer. Now, I'm going to qualify that. That's historical diagnosis, right? Where we often miss it or it's too late. With early detection, we should be able to move that needle. We might pick it up earlier following exposure. So hopefully that answers. And Diane has a comment.
Yeah, and I actually have a question. So those of us who are patients and have lung cancer, have had it for 1 time, 2 times, however many times, what's the correlation between continued exposure to radon and our current disease? I think people don't tend to talk about that a lot, and I do know there is an impact.
It's a great question, Diane. The answer is nobody knows. For the first time, Canadians with lung cancer are living long enough for this to be examined and questioned. So this is a question that we can start asking, I think, where you have people with lung cancer who are now 5 years out, 10 years out, where we can now look at further exposures and look at risk of secondary disease and other factors that relate perhaps to your treatment and other lifestyle factors that, of course, are modified as a consequence of being a survivor.
Thank you.
Well, we're a little bit over time. I'd like to thank everybody for joining us, and thank you, Erin. Thank you, Diane. I know that it was fascinating and I learned a lot. I hope everyone else did too. And we will send out a link when this goes up on our websites for reporting to anyone who was unable to join us today.
Thank you, everyone.
Thank you,
Thank you.
everyone.
Thank you.
Bye.
Bye.